Hi everyone. I hope that you are keeping well with your friends and family. I'm Ashish Das. I'm currently working as an IT solution architect, and I have more than a decade of experience in IT software and solution. Uh, in our earlier sessions, we discussed and built basic understanding on Google Cloud Platform. And also we discussed few compute services such as virtual machine and Google Kubernetes engine, etc. In today's session, we're gonna shift our focus to build the understanding on some networking services. Uh, in next 30 to 40 minutes, what we're gonna cover is we'll focus on different networking services such as basically we'll build understanding on cloud VPC. So what is a cloud VPC? Why it is needed in today's world, or in why Google Cloud VPC is required, and then followed by a demo to create a VPC network in GCP platform to concrete our understanding on that. Yeah, so this is what the agenda for today is. So, okay, while I was in college, I always had this question in mind that what exactly is VPC and why do we need a VPC? Yeah, so this was a burning question at that time because, uh, I mean, students who are into core networking or core computer science, obviously they probably had an answer on that. But yeah, but other students they didn't had at the time. So let's in today's corporate network, or maybe in the on-premise data center, so no one on the internet see the data exchange between an application and the database, right? So if let's suppose we have a corporate data center that is located in Mumbai, and we have an internal application that is known as sales application, which is talking to different database. Suppose that only one database. So now, no one from outside this network should be able to access this database, or should be able to access anything for this sales application. Yeah. So we have an application which is talking to the database, and no one see the communication between the application and the database. So should anyone from the internet directly connect to the database first of all, or should somebody from the outside directly connect to that database? The answer is obviously, most probably the answer is no. uh, we need to first connect to the corporate network. Yeah. And then we can access the internal application or the database. So the corporate network provides a secure internal network protecting the resources, data, and the communication between these uh, applications. Yeah. So how do we create this? And this, in the sense, this our own private network in the cloud. So the option in cloud is creating a VPC, that is a virtual private cloud. So now what is Google Cloud VPC? Google Cloud VPC is our own isolated network in Google Cloud, GCP Cloud. Yeah. So when you say like network traffics within a VPC is isolated, it is not available to all the other Google Cloud VPC. So you can see here, uh, we can basically control all the traffics which are coming in and going out of the VPC. So the best practice which is given by the GCP resources is to whether we are creating compute resources or storage resources or databases. So every resource, it has to be create inside a VPC. Yeah, this should, why? Because this should help to secure the resources from unauthorized access, and it will also enable secure communication uh, on our Google Cloud resources. And yeah, one important thing to remember is in Google Cloud, this VPC is a global phenomena, like global resources. Unlike in AWS, if you're familiar with AWS, where VPC is associated with the specific region, but in Google Cloud, VPC is a global resource. It can contain resources from any region. So inside VPC, there would be different subnetworks. Yeah. So these subnetworks can have one or more region. Uh, but the VPC as an entire phenomena, it is a global uh, terminology. So basically, this VPC network provides four different functionality. What it does? This VPC, it provides connectivity for GCP resources such as your compute agents. So there are compute agents here which are at, let's suppose, in the here region in US East 1 and US East 2. Yeah, so this provides connectivity for GCP resources. It offers a built-in internal load balancing. Yeah, it is an internal load balancing. So such as TCP UDP or HTTPS or some other types of load balancing. Also, it connects to on-premise networks using cloud VPN tunnel or other such as cloud interconnect attachment. So, for an example, if we have an we have a data on-premise data center and we have one our Google Cloud network. So, if you want to connect these two, how we can connect? We can connect with cloud VPN tunnel and or cloud interconnect attachment. So for this also, VPC helps. I mean, VPC only connect via this VPC route gateway. It connects these two. Also, it distributes traffic from cloud external load balancer to the backends. Yeah, so there are sometimes the routing is also there. So you're inside this VPD, the traffics are getting distributed to different resources which are present in the VPC. So now, what are subnets? Subnet or so we can say this is a subnet, right? See here it is there subnet 1, subnet 2, subnet 3. So what are subnet? So subnet or subnetwork is it is not the same thing as VPC, but in simple words, a subnet helps to separate public resources from private resources. How? We'll understand that a bit. Let me explain. So we know that different type of resources are created on the cloud, yes, such as database, compute engine, load balancer, etc. But the catch here is each type of resources has its own access needs. For an example, this load balancer here, which is there, okay, load balancer, typically we use load balancer to expose the web application to the outside world, right? So load balancer are accessible from internet. So we should be able to access the load balancer from the internet. So a load balancer is basically a public resource. Yeah. On the other hand, if we have a compute engine, okay, or let's suppose have a storage services, cloud SQL. Yeah. So these are not accessible from the internet. I mean, this should not be accessible from internet because it contains very sensitive data about the organization. This should not be accessible from the internet. So our so these are basically known as our private resources. So how it should be accessed? So they should, I mean, in the network, we should always access these private resources with a proper route to the via Google Cloud Load Balancer, and this Load Balancer will talk to, let's suppose, will Cloud Load Balancer. Okay, this is the user. User will access to this Cloud Load Balancer link, and Cloud Load Balancer will gonna talk to compute engine will gonna talk to the backend services which are suppose cloud SQL or cloud storage or other services. Yeah, and also the applications within a defined network should be able to access other resources from the internet as well. Yeah. uh, for an example, the compute engine and database should not be accessible. They should only be accessible to applications which are inside the network. Yeah. Uh, so now the question here is, how do we separate these private and public resources inside a VPC? Yeah. So the option is to create separate subnet. So when you say subnet, subnetwork for private and public resources. In the subnet where public resources are present, we can allow connection from the internet. Okay, let me just share this one. Yeah. Yeah. So we can create all our private, all our public resources in the subnet one. So which is known as public subnet, and we can create our private resources in the private subnet, and we can allow communication from public subnet to private subnet. Yeah. So by default, actually, uh, both if both are in the same VPC, so all the resources in the public subnet, they will be able to talk to private subnet. However, uh, uh, that also can be denied. But yeah, so the main idea is we want to enable a secure channel to the resources of public subnet from internet, and want to enable a secure channel or communication from the resources of public subnet to the resources of private subnet. Yeah. uh, Correct. So a subnet helps to separate the public resources from the private resources. So this is what we got. So another reason is that we can create subnet to distribute the resources across the multiple region, and for high availability. For an example, say in this diagram. So even if this is my VPC, and we have resources in US West one, resources in US West East one, we can add multiple subnets of different regions, such as uh, Asia South one, which or for Mumbai location. Yeah. So so all the resources we can we can achieve high availability. For that also VPC is used. Yeah. In multiple region, so we can create multiple subnets, and we can create compute engine instances in those subnets. Yeah. So when we create different subnets for private and public resources, within a VPC, we could have a public subnet and private subnet. So that we got. So resources in the public subnets can be accessed from internet. Resources in private subnet, there's those cannot be accessed from the internet. So this also we discussed. Uh, in a Google Cloud, when we create a VPC, it is a global. Yeah, we learned that, but the resources inside the VPC can be regional or multi-regional. Okay, this is also one point we want to take away. Uh, okay, next, let me just open the Google Cloud Console to create a demo VPC to concrete our understanding. I mean, obviously, there are a lot of information. I just don't want to bombard with a lot of information without concrete the understanding. Just a sec. Let me just open. Yeah, so let me just select this ADB project. I can navigate to VPC network. So by default, every project has a default VPC. Yeah, so you can see here the default VPC. So if you're gonna click that, uh, yeah, obviously we can create our own VPC as well. So if you will see, so this default VPC, because GCP is spreaded across 36 region. Yeah, so that is why for each region there is an subnet present. So you can see here for region US Center 1, sub stack type is IPv4. This is the IP range, no external IP, and this is the gateway. Yeah, so this is the default one. We can create our own VPC. How to create? So create a VPC network. Click on here. Let me name it AD VPC 3. Yeah, so VPC network, whether it is for IPv4 or IPv6. Okay, as of now, we'll go for the IPv4. Okay, this is an interesting option which is the subnet creation mode. What it is? Okay, when we create our own VPC, we have two options. One is, as we can see, one is auto mode VPC network or custom mode VPC network. So basically, Google offer these two types of VPC network determined by their subnet creation mode. So when we go for auto mode VPC network, so one subnet from each region is automatically created. Yes, and these automatically created subnets use a set of predefined IPv4 ranges. Yeah, we don't have like complete control on that, but we can add our own IPv4 range after that. But yeah, but by default, it will be automatically created subnets using certain predefined IPv4 range. When you go for the custom mode VPC network, so the subnets are not created automatically. Yeah, so obviously this is a layman. Then this type of network provides complete control. Why complete control? Because we need to add our own subnets and own IP ranges, so we can decide which subnets to create in which regions. So we need to specify those details, and also obviously we can customize our firewall rules, etc. So the question is, can we switch from a auto mode to custom mode? We can switch a VPC from auto mode to custom mode, uh, but this is one-way conversion. Basically, custom mode VPC network cannot be changed to auto mode, because in auto mode only a predefined IPv4 ranges are there, right? So uh, once it is on custom mode, obviously that predefined is diluted now, so it cannot be converted to an auto mode network again. And one major thing also, in auto mode only IPv4 uh, ranges are possible, but in custom mode both IPv4 and IPv6 those are possible. Yeah, so okay, let me just create this one. Let me give IPv4 range 10.0.0.0/9. Okay, plus 28. Okay, so this IPv4 range, so this is uh, nothing what we, this is something like which range of IP addresses are allowed into this network. So in networking terminology, we call it CIDR notation. I think this is classless something. I am not able to recollect the full form, but what it is a bit of complex notation. So what it means is, in IPv4 there are total 32 bit, right? Okay, in normal scenario, if you want to give a range, how you will give a range? You'll give a start IP address, you'll give an end IP address, right? So, and you will say, okay, all the continuous IP address from start to end, so both will be part of this particular range. But is there a different approach or a simpler approach? So that is where the CIDR block notation is there. So here, so this is my 10.0.0.10.0.0.0. So this is my starting address. So out of in IPv4 there are 32 bit. Out of these 32 bits, the 28 bit is fixed. So only the last 4 bit can be changed. Okay, if you want to visualize a bit more, I'll not go to that complex notation. I'll just CIDR.xyz. There is a beautiful tool somebody has developed to visualize that. Yeah. So here 10.88.135.144/28. Slash 28 means 28 bits. So bits which are colored here, so those are fixed. Only the last 4 digit can be changed. So we can have, so if I'll write it here 32, all the 32 bits are only one IP address is allowed. If I'll write here 31, only last bit is different. So the IP address which is allowed in this range is this this either, I mean, this colored notation are fixed, and this gray one, it can be 0 or 1, right? So only two IP address range, only two IP addresses allowed in this range. So if I'll add here 30, So the last two bits are now can be changeable. So the total number of IP address count is 2 to the power 2, that is 4. Yeah. Similarly, if we'll add here 29, now last 3 digit are changeable. So total number of IP address count will be 2 to the power 3. So that is 8. Yeah. So this is my first usable IP. This is my last usable IP. This is my net mark. So yeah, so I'm not going in deeper into this. Obviously, it needs entire workshop on its own to discuss. But yeah, so we just build a basic understanding about what is this CIDR notation, how we denote different IP address ranges in the CIDR notation. Yeah, moving back to our IPC VPC creation. Okay, so while creating this, we have few options. One is private Google access and this flow logs. So if we enable private Google access, then our VM inside or resources inside that subnet can talk to Google APIs using the private IP. Yeah. So whenever suppose we want to talk to any resources, it is better to use private IP because if we use private IP, the communication happens within the network. So, and as soon as we'll use the public IP, the communication will goes over the internet, and obviously that is vulnerable, right? So that's the reason why it is better to use private IP for the internal resource communication. And yeah, so this is if you'll just hover here, so it will written the set whether the VM in the subnet access Google services without assigning external IP addresses or not. Yeah. So another option is flow logs. What are flow logs? If you want to see the traffics which are flowing in and out of the subnet, and if we want to troubleshoot any VPC related network issues, we may enable the flow logs. So this turning on this VPC flow logs does not affect any performance, but some systems generate a large number of logs which can increase the cost in logging. Okay, as of now, I don't want to make it on because I'm creating a demo. Okay, let me just create it. Yeah, so major thing is here, add the name. Let's suppose I'm adding very custom one, custom subnet. And to add a region, let's suppose US Central 1. Yeah, done. Next options are firewall rules. Okay, so let's before selecting this, let's talk about a bit about firewall rules. So what are these firewall rules, and what is the need of these firewall rules? Yeah. So basically, we can control traffic going in and out of the network, right? But how? Each VPC network elements, each VPC, by default, it implements a distributed virtual firewall so that we can configure. So these firewall rules allow us to control which packets are allowed to travel or which are not to or from their destination. So if you can see here, so each firewall rule, whether it's a type, whether it's an ingress or outgress, ingress or egress. Ingress is the traffics which are coming into our network, and egress is the traffics which are going out of our network. Yeah. So whether any targets or any specific tags, so that we can allow here. So we can create our own firewall rules as well. So these are the default firewall rules which are associated for any while creation of any subnet. The filters, these are the IP ranges. These are CIDR block what we have selected. The protocols, whether it's ICMP or TCP or any other protocols it want to follow, and whether action, whether it should allow or deny, and the priority. Okay, so each firewall rule has a priority assigned to it. So a number, basically it's a number between 0 and 65535. Yeah, so 65535. 65535 is the lowest priority, 0 is the highest priority. Okay, so by default, all ingress are denied, and this is having 6 5 priorities 65535. By default, all ingress, so like that means the traffics which are coming into our subnets, this is denied. Yeah. Okay, these are not physical rules, obviously. These are implied rules. So this default implied rules allows all the egress from the network. So this is again a default firewall rule. It allow all the egress, like the traffics which are going out of the network, but it has a priority 65535. Okay. So these default rules, it cannot be deleted. But if you want to, let's suppose if you want to deny any egress, or if you want to allow any ingress, we can override the default rules. So basically, we need to create one firewall rules, and we want to assign a priority which is lower. The value should be lower than this value, like 655. So let's suppose we want to allow some sort of ingress or deny some sort of ingress. So we want to create a firewall rule and assign the priority 65533. So this will override this priority. Okay, and our defined firewall will gonna work, and this will gonna be overridden. Yeah, so this is how it works while creating a VPC network in GCP. So basically, as soon as we use any number which is basically less than that of the rule that has been configured here, or any default number present here, so that will override these default rules. So whenever we created default VPC, default VPC has 4 additional rules. So uh, these are having 65534 priority. What are these? This allow allow custom ingress, allow SSH, allow RDP, allow ICMP. Yeah. Uh, Obviously, so these are traffics, so SSH traffics, or if you are using a Windows machine, RDP traffics, remote desktop protocol, or ICMP traffics. So these are having priority 65534. Okay, so and obviously we can select, we can define the port or port as well. So for an example, for this SSH, already this port on port 22 or protocol TCP, SSH is allowed. Similarly for RDP on port 3389 protocol TCP, this RDP is allowed. Yeah, similarly we can also define our own. So by default, let me just allow these uh, regional, global. MTU, let's suppose maximum transaction unit is 1460. Let me create now. Yeah, it will gonna take some time. Should not take more than 1 minute though. Yeah. So what I'm gonna do? So this is my okay. If I'll go to this VPC, we can see a subnet is added here. This is my gateway 10.0.0.1. Private access is off. Low logs is off. External IP ranges is none. Yeah. So this is what we created. So now what I'll do. Okay. So for a demo purpose, what I'll gonna create is I'll gonna create 3 virtual machines. Okay. This will be my this will be my VM1. Okay, what I'll create is I'll create VM1 and VM2 in default network, and I'll create a custom mode network, which we already created, and I'll create another VM here in this custom mode network, and we'll try to ping from this VM to this VM, this VM to this VM. Theoretically, what we learn that the communication from different VPC is not allowed, right? By default, it should not be allowed. So when we'll ping from VM1 to VM3, let's suppose here this is VM3. When we'll ping from VM1 to VM3, it should not allowed. When we'll ping from VM1 to VM2, this should be allowed. Yeah, so we're gonna create a demo for this. Okay, so here add VM instance. Let me create 3 VM instance. Yeah, let me just name is AD default instance 1. Region is fine. This is fine. This is with networking. Yeah, this is with the default network. Okay. So let me create this. Now this is, I'll create AD again, in the same VPC, default VPC, VM instance 2. Let me change the region here. I suppose US West 3. Okay. Now this also is using default network. I mean default VPC. Yeah. So I'll just add create. Yeah. So this one is ready. AID default instance 1 and 2 both will be created. Now let me create another instance. This I'll use custom network using our custom VPC that we created already. So AID custom VM instance 1. Yeah, if we will just scroll down and allow net advanced option, networking, and here we want to change to this AID VPC3 that we created here, right? AID VPC3. So let's select that. But while you're selecting the subnet, there is no subnetwork. Why? Because if we'll see this custom subnetwork, it was in US Central 1 region. But here it is, if you'll scroll up, it will not be in US Central 1, it will be in US West 4. So if we'll change here to US Central 1, any zone, now it will automatically select this particular subnet with all the CIDR blocks, firewall rules, whatever we have created are associated with that VPC. Yeah, IPv4, etc., all the fine. I'll take all the default option as of now. Create. So now my all three instances are ready. Let me SSH from default instance 1. Yeah. So this is default instance 1. We'll ping to instance 2. How to ping? Ping and IP. The G is not working in my keyboard. Anyway, so default instance 1, we need to ping to the internal IP of default instance 2. Should the ping work? Yes, because both are in the same VPC and it is working. Yeah. Now let's ping from default instance 1 to default instance, custom instance 1. Should the ping work? No, because both are in different VPC. Let's see that. Ping 10.0.0.2. Yeah, as we expected, this is not working. Now, from instance 2 to instance 1, let's close this and open the SSH1 instance 2. Yeah, ping. Yeah, this is working as expected. From default VM 2 to default VM 1. Let's ping to the custom machine, like the VM created with the custom VPC. It should not work. Yeah, as expected, this is not working. Yeah. All right. So what we can see here is by creating a network and by assigning resources to this network, we could control the communication between those resources, and that is one of the main reason why we need to create the resources inside the network. And ideally, all the resources that we need to create, they should be created in a custom VPC, right? So thereby why? The reason is we can control the communication between different resources, and also we can control traffic in and out of the specific network. And in VPC, we also have an option where we can actually connect these two networks together. So that is a different concept called VPC peering. So we can actually say these instances in this network A, default network can communicate to custom network, and they can talk to each other. This concept is something called network peering or VPC network peering. Okay. Anyway, so by default that is not allowed. We need to build something for that. Uh, so basically, so in this entire demo, what I saw is how to create a custom network, how to create a VPC in Google Cloud, and we learned how to create instances in that custom network. And also we saw that instances in the custom network cannot talk to instances in the default network by default, right? There are some other. Okay, let me just delete these VMs. Otherwise, it will gonna exhaust my budget. Delete. We can also, okay, while creating a VPC, we can also define our routes. So basically, routes that tells VM instances and VPC network how to send traffic from one instance to the destination. Yeah, either inside the network or outside the Google Cloud network. So each VPC network comes with the system generated routes. Basically, these routes are, I mean, how to route traffic among different subnets and send traffics from eligible instances to the internet. And it also comes with forwarding rules. So while the routes govern traffic leaving an instance, forwarding rules directly to the Google Cloud resources inside a VPC network. So based on the IP address protocol or different ports. So those also can be configured. There is one concept called shared VPC and VPC peering that we already discussed. Okay, let me just close this one. Yeah. So shared VPC and VPC network peering. What are these two routes we already covered? Okay, what is this two? Okay, shared VPC is basically we can create a VPC network from one project called a host project and two other projects in the Google Cloud organization. So basically, we can grant access to entire shared VPC network or selected subnets. Yeah, obviously those can be controlled by access management permissions. Uh, and this what will help? I mean, how this will help? So this will let the organization provide the centralized control over a common network while maintaining organization flexibility. So shared VPC is especially useful in the very large organization as well. Similarly, VPC network peering. VPC network peering is basically a SaaS ecosystem in Google Cloud. So what it does, it makes services available privately across different VPC network, but inside Google Cloud. Yeah, whether the network are in the same project or different project, or the projects are in the different organization. Yeah, so this is the basic what I wanted to cover today. Okay, before closing the session, one other thing I wanted to cover is hybrid cloud. A bit of about hybrid cloud. Okay, for an hybrid cloud is basically the cloud having multiple both public cloud, private, and multiple public cloud. So, for an example, so let's suppose we have an on-premise. We have our on-premise data center, and we have a Google Cloud platform. So, how to communicate between these two? So, we have multiple options. Number one is we can have Cloud VPN. Cloud VPN. So Cloud VPN is only, I mean, it will let us the VPC network to the physical on-premise network or another cloud provider by using a secured VPN network. Yeah. The second option is dedicated internet. What is this? Okay, there are multiple options again here. So one is cloud interconnect. One is partner interconnect. I'm just forgetting. Yeah, so basically there are two options. Again, inside Cloud VPN also, I mean, there are different communication can happen between layer 2 and layer 3. In layer 2, then there can be peer-to-peer network connection. There can be and in layer 2 we can have cloud interconnect, you can have partner interconnect, we can have dedicated interconnect. So the mode I mean, it is again, it's a through point to point connection only, but the only difference is for partner interconnect there will be another part. I mean, obviously it is very high speed. Cloud interconnect, obviously it connect a VPC network, the on-premise network, by using a very high speed physical connection. Yeah, and this physical connection, it can be Google's physical connection can be used, or any partner defined network can be used for that. So when a partner defined networks is used, they call as a partner interconnect. Otherwise, if you want to add dedicated link between that, we call as dedicated internet. Yeah, and if you want a low volume connection channel between our on-premise to Google Cloud, we can go for Cloud VPN. And obviously, there are security measures are already being taken to secure the bytes. I think it uses IKE1 and IKE2 protocol. So this is Internet Key Exchange protocol are being used. Yeah, so obviously we can have a demo on this hybrid network cloud in later on the subsequent sessions. Obviously, it will consume entire session altogether. Yeah, so that's it. What I wanted to cover in today's session. Hope you built your understanding on why VPC is required, and we obviously saw how to create a VPC in GCP, and we created VM using default network and custom VPC network, and we tested the ping. Yeah. So if you have any questions or any feedback or any other topic you want us to cover, maybe you can connect us on contact@imesh.ai. Yeah, that's it for today. Thank you.